Hi, and welcome back to Today I Learned Climate. I'm your host, Laur Fisher from the MIT Environmental Solutions Initiative. Electric vehicles, or EVs, are seeing an incredible surge around the world right now. In 2010, there were less than 20,000 EVs on the road. 10 years later, there's over 10 million. In the US, EVs are still only about 2% of new car sales, but it's looking like that will change. Several U.S. states are requiring that all new cars be zero emissions by 2035. And some of the world's largest car makers, including Volvo, Honda, and GM, plan to be all electric by around that same year. EVs are being touted as a major solution to climate change, but why is that? How do they work? And what kinds of changes are needed as more electric cars hit the road? To dig into this, we brought in someone who studies transportation technology.
Hi, my name's David Keith. I'm a professor at the MIT Sloan School of Management in the System Dynamics group, where I study the emergence of new technologies in the automotive industry.
Today, most cars on the road are powered by gasoline, also called petrol, which is derived from the oil that we pump out of the ground. And when cars burn gasoline, it sends all kinds of pollutants into the air out the tailpipe, including the greenhouse gas CO2.
So in the order of 30% of US greenhouse gas emissions come from the transportation sector broadly, and about 2/3 of that is from what we call light-duty vehicles, which is cars and pickup trucks. So about 20% of all greenhouse gas emissions in the United States come from what we think of as cars.
Let's start by breaking down how electric vehicles are different from gas-powered cars.
In the gasoline vehicles that most of us have today, we have an engine up the front, and then we have a gas tank in the back. An electric car replaces all of that with an electric powertrain. So instead of a gas tank, we have a battery. And instead of an internal combustion engine, we have an electric motor. So the main benefit of electric cars is that they don't produce the emissions that come from the combustion of gasoline that contribute to climate change. And the other is particulate emissions, small particles that are left over when we burn gasoline that can be very harmful to human health and contributes to the smog that we see in some big cities like Los Angeles. Electric vehicles don't have tailpipe emissions. They don't even have a tailpipe.
So if we switch to electric vehicles, then no more greenhouse gases, no more pollution, right? Well, unfortunately, it is more complicated than that.
An electric vehicle is only as green as the electricity that goes into it. Those emissions could be zero or nearly zero if that electricity is coming from renewables such as solar and wind. But on the US electricity grid today, we have a lot of gas and some coal and other things as well.
That means EVs can still cause greenhouse gas emissions, but instead of at the tailpipe, it's at the power plant.
The vision for electric vehicles into the future and the opportunity is that as the grid gets greener, those electric cars that are already on the road will continue to get greener because the fuel we're putting in them have lower and lower carbon footprint.
So this makes me wonder, because our electric grid still relies on fossil fuels, does switching from gas cars to electric cars really make a difference today?
We want the grid to get greener, but not having green electricity is not really a reason to not electrify our vehicles. An electric vehicle running on coal has the fuel economy equivalent in the order of about 50 to 60 miles per gallon. So the dirtiest electric vehicle looks something like our best gasoline vehicles that are available today. And an electric vehicle that's running on a really clean electricity supply, the New England or the Pacific Northwest, or these places, the fuel economy equivalent, the MPGE is what we call it, it's up into the hundreds, so 110, 120 miles per gallon. It's a substantial improvement on the vehicles that run on gasoline.
But ramping up EVs is not without its bumps in the road. If we want to keep driving our cars and want to seriously slow down climate change, we also might need to think about how we use cars today.
In our work at MIT, we talk a lot about the norms that exist around vehicle ownership. Right? We have 100 years of history that has imprinted in our brains what car ownership involves, how fast it drives, how you refuel it, how long it takes to refuel, all of these things. What we've observed is that we don't buy a vehicle that meets the average needs we have on a day-to-day basis. We buy a car that can serve our 99th percentile needs, which is the long driving holiday that we're going to take, or towing the boat, or whatever it is. The sort of first wave of electric vehicles had about a 100-mile range, driving range, and now we're up into the 300-mile range, and yet almost every driver on almost every day will not use that 300 miles of driving range that they have.
Why does this matter?
Range is expensive because the more range we want, the more batteries we need to put into the car. There's been a profound reduction in the cost of these batteries over the last decade. Batteries are about 1/6 the price they were. But, we're still talking $10,000 to $15,000 just for the battery to go into the car.
Currently, making batteries for cars, but also for things like our laptops and cell phones, carries other costs too. Environmental costs, like water issues that arise from mining lithium, which is one of the metals that batteries need. Societal costs, like the forced and child labor that still exists today in the cobalt mines of the Democratic Republic of the Congo. We have an entire episode in season 2 that focuses on this called Cleaning Up Clean Tech, if you want to learn more about it. But fewer batteries is not the direction that the market is going in.
What we're seeing is consumers tell us they want electric vehicles that operate like their gasoline vehicles operate today, which is long range and fast refueling. And it really feels like we're reaching a place in the market where the technology is maturing and we're seeing many more affordable and long-range EVs. The latest, greatest electric vehicles we have are able to recharge in 20 minutes.
It doesn't only matter how long it takes to charge an EV, but also where to charge it. Chargers are popping up, at gas stations, but more so where people are already parking their cars for a long time. At home, but also in lampposts and parking meters on city streets, in parking garages, and shopping mall parking lots. What also matters is when we charge our cars.
If 100% of vehicles on the road today were electric, our electricity consumption would go up in total, and it would go up quite considerably, in the order of about 20%. The aggregate amount of energy we're using matters, but also the time of day that we're charging the vehicles matters a lot as well. If we all charged our electric vehicles overnight while we slept, and when electricity demand is relatively low, then supplying all that additional electricity probably wouldn't have a huge impact on the electricity grid. But if we all want to charge at, 5 p.m. on a Friday afternoon in the middle of summer, when the peak load on the grid is already very high, then adding that additional load could be really impactful and costly.
By the way, to understand all this better, we have an entire episode in season 2 talking about how the electric grid works, and we recommend that you check it out. Okay, so with all of these innovations and demand increasing, EV sales around the world have doubled between 2020 and 2021. But because of how the car market works, it still might be a while before most cars on the road are electric.
A new car sold today will be on the road for the next 15 to 20 years. But it's actually only about 20 to 30% of the population who buy new cars. The market for used cars is about twice as big as the market for new cars. And, this market hasn't existed for long enough that those cars have filtered down such that there's a really robust market for used electric vehicles.
One way to build up the market for EVs is to make them cheaper to buy.
Many governments and others have incentivized the purchase of electric vehicles. But as I just said, the people who are buying those new EVs and who are often the ones eligible for those incentives are moderate to higher income households frequently. There are still a bunch of questions around equity of access.
Another way to get more people buying EVs is to tout how cool they are.
It's got a targeted 775 pound-feet of torque. It's targeted to go from 0 to 60 in the mid-4-second range. It's a driving experience that's pure, unfiltered exhilaration from the moment you hit the accelerator. Oh, and it's an F-150. Introducing the all-electric F-150 Lightning, the smartest, most innovative F-150 we've ever built.
The F-150 pickup is the best-selling vehicle in America, and Ford is betting that its new electric version can appeal to an entirely new audience. So there are still challenges to work out. Companies and researchers are working to make batteries less toxic to produce, as well as more easily recyclable, or repurposing them for things like storing electricity from wind and solar. We have some great resources in our show notes on all of these topics that we recommend you check out. So as these things get worked out, we're going to be seeing many more electric cars on the road in the coming years, and there's good reason for that.
There is an environmental need in the automotive space to introduce zero-emission vehicles, given that 20% of emissions come from cars, and electric vehicles appear to be the most compelling solution to do that for passenger cars and light trucks. I view EVs as one part of the solution, but certainly not sufficient as we think about sort of sustainable mobility more broadly. A limitation of purely going down the EV path is that we're not addressing some of those broader questions about traffic congestion or road safety. And there are many people in society who can't afford to own a car at all. But that's probably a conversation for another day.
That is a conversation that we're having another day. In fact, it's our next episode coming out soon. That's our episode for today. Please rate and subscribe to TIL on Spotify, Apple, Google, or wherever you get your podcasts. As always, we have an accompanying educator guide to help teach about electric cars in the middle and high school classroom. Check it out at climate.mit.edu/educators. We'd love to hear from you. What climate topics should we cover? What questions can we answer? Email us at tilclimate@mit.edu, and on Twitter, we're at tilclimate. Thanks to Professor David Keith of the MIT Sloan School of Management for joining us, and thank you for listening.